Hi, today we're going to look at the review sheet and I'm going to show you all of the answers, okay? This is review from 0.1 to 0.7 for you to prepare for the test on Monday, okay? So from the first question, let's take a look. Determine the slope of a line parallel to -1, -2, and 3, 2. First, what I want you to do is dot -1, -2. Go to the left-hand side, -1, and down 2 for the first point, okay? Then you're going to dot 3, 2. Go over to the right 3 spaces, okay? And then up 2, and you get the other point, 3, 2. Now that I have dotted these two lines, I'm going to connect it, okay? Once I have connected, I can do rise over run. Let's go up, 1, 2, 3, 4. That's 4 times. That's rise 4, and then over 1, 2, 3, 4. That's run 4. So 4 over 4, that is 1. So the slope of this line is 1. Now that I have graphed the first line, let's graph the second line, okay? So parallel to this point, I'm going to dot a new point. Parallel to this point, I'm going to dot a new point. Alternatively, you can dot one point, and then you can do rise over 1, 1, 2, 3, 4, and then over 1, 2, 3, 4 for the other point, okay? And then you're going to get a line, and you can connect it. So my points are -3, 0, and 0, 4. Now, let's go to see how we can determine the slope of a line that's perpendicular to this line. So the slope of the line that's perpendicular to this would have to be the opposite reciprocal. We have 1 here, so let's turn the 1 into a -1, okay? And if you flip the 1 upside down, that is also 1 over 1. So we have -1 as the answer, okay? So next, let's go over the second question, okay? Second question. Graph the lines of the grid provided, okay? So in order to do this, you're going to go to your calculator and type in y equals. And then you're going to do alpha x to get the fraction, okay? Once you get the fraction, you're going to type in the first equation, okay? And then you're going to type in the second equation and the third equation, and then click graph. That should generate the graph for you. Once you have the graph, you're going to put the equation right next to the lines that you're graphing, okay? So this is what you need to do on the test if we ask you to graph an equation, okay? Next, for number 3. There are 2 lines that are provided, A and B, okay? We're asked to write the equations, okay? When you're asked to write the equations, the first thing that you're going to do is try and figure out the slope, right? So let's pick a point on line A, which is this point right here, and let's do rise over run, 1, 2, and then over 1. So that is 2 over 1 is the first slope, okay? And then let's find the y-intercept. The y-intercept of this line is the point that intersects the y-axis. So here, this is the point right here, and the coordinate is 0, 6. So therefore, we're going to write +6 as the y-intercept. That completes our first equation, A. Let's go to the second line right here for B. Okay, let's pick a point over here as well. And then let's do rise over run. Rise over run. That's 2 over 1. That is the slope of the second line as well. Okay? Because these 2 lines are parallel. So it makes sense that the slope are the same between the 2 lines. Okay, how do we find the y-intercept? Let's go to this line and take the point that intersects the y-axis. That is our y-intercept, okay? So then let's write down the coordinate 0, -4. And let's write the y-intercept as -4, okay? This completes our two equations, okay? Moving on, we're going to question number 4. This is just drawing two lines, right? Parallel line and perpendicular line. Remember, parallel line are two lines that do not touch. And perpendicular is a line that looks, two lines that looks like they cross or in the T shape, okay? So for question number 5, we are asked to put the standard form equation 2y plus 3x equals 1 into the y equals format. Remember, we have to do that before we graph any linear equation, right? So let's do that. Let's put this into the y equals format. First, we have to isolate the y. In order to isolate the y, we're going to move the 3x. How do we move it? We're going to do -3x on both sides, okay? Because 1 minus 3x, they're not like terms. We're going to write it down and we're not going to combine it. Next, we're going to divide both sides by 2 because we're still trying to isolate the y, okay? Once we have divided by 2, we're going to distribute it to the 2 across both of the terms. So that would leave us with y equals 1/2 minus 3 over 2x, okay? Notice that choice number 4 is exactly the same as this equation, except the terms have different orders, okay? When the two terms have different orders, it is still the same equation. Remember that for the regions, okay? Now, let's move on to question number 6. Question number 6 looks like it's a little bit complicated, okay? However, what I did was do it two different ways to eliminate two of the choices, okay? Let's take a look at this question. Y equals 2 over 3x plus 1, okay? We're asked, what is the line that is perpendicular to this line, right? Let's take the slope, 2 over 3. In order for the line to be perpendicular to this equation, we have to do the opposite reciprocal slope, right? When we do that, we're going to turn the plus to the negative and then flip the top and the bottom. We get 3 over 2. That's the slope for our new equation, okay? That's the slope for our new equation. Immediately, we can eliminate the choices that don't have this slope, which is choice 3 and 4. And now we take a look at both of our answers. They're both in standard form. So let's take the first one and put it into y equals format so we can see what the slope is. If you follow the steps right here, you're going to get down to the answer, which is 6 minus 3 over 2x. This slope is what we want, okay? So the answer is choice 1, okay? Why is the second one not the answer? If you work it out and isolate the y and put this into y equals format, you're going to get the slope as 3 over 2. That's not the one that we're looking for. Remember, it's negative reciprocal. So choice number 1 is our answer, okay? For question number 7, it is pretty straightforward, okay? We're going to use the Pythagorean theorem to help us solve. But before that, we must graph the 2 points, okay? Let's do that. Let's graph 6, 5, okay? And 0, 2, right here. Once we graph this line, we're going to drop down and create a triangle like we did in class. Once we created this right triangle, remember, the triangle that's opposite, okay, the right angle is our hypotenuse right here. That's the distance that we're trying to find. So the two sides, what is the distance of the two sides? The first one is 3, right? We can count the boxes. The second one is 6. We can count the boxes, okay? Then what we're going to do is put the distances of 3 and 6 and x into our Pythagorean theorem equation. So 3 times 3 is 9. 6 times 6 is 36. And then we're going to write x to the square down over here. Once we solve for it, we must do radical on both sides to cancel out the square. Finally, okay, we're going to get radical 45. Now, we have to put that radical 45 into the simplest radical form. How do we do that? We did that in class, remember? We create a factor tree. 45 divides into 5 and 9. Okay, 5 times 9 is 45. Now, can we divide 5 anymore? No, we cannot. Can we divide 9 anymore? Yes, we can. We can divide 9 by 3, and then we get 3. So now, let's look for twins. 3 and 3 are a pair of twins. So they're going to come out of the house just like that. But they're going to come out of the house only once. And then we're going to draw the house and put what's left over inside the house. And what's left over is our 5, right? So the answer is 3 radical 5. Okay? So next, let's move on to the final problems. Okay? Okay. So the last two problems. Question number 8. Okay? Question number 8 is similar to the question we had before, except we just need to find out the slope for this line A and B, right? So we graph these 2 points just like we graphed it before. How do we find the slope? We go up 1, 2, 3 to find the rise, and then we go over 6 boxes to find the run. So we write rise over run 3 over 6. And if we simplify this in the calculator, we can get 1 over 2. Okay? So now draw and label CD anywhere on the grid that is parallel to AB. Now, we can dot 1 point first and then do the same slope. Up 1 and over 2 to get the second point, and then we can draw CD right here, okay? So the slope of the parallel line must be the same. A half equals half, okay? Now, finally, we're at question number 9. Remember, question number 9, we must prove 2 different points, okay? Perpendicular bisector, right? We have to prove that AB is the perpendicular bisector of CD, okay? First, we're going to prove that AB is perpendicular to CD, and then we're going to prove that AB is a bisector of CD, okay? So, in order to prove something is a perpendicular of something else, we're going to rely on the slope. Remember, when 2 lines are perpendicular, one is the opposite reciprocal slope of the other. So let's draw the rise over run for A and B. Okay, A and B. Okay, so let's do rise over run. If you do rise over run for AB, you're going to get negative 3 over 3. Okay, negative 3 over 3. Okay, so it goes down and over. Okay, so that is ultimately negative 1, right? But I'm still going to write negative 3 over 3. Let's draw the rise over run for C and D. C and D. It's 3 over 3. Okay, 3 over 3. So that looks good. One is the opposite reciprocal of the other. So we can say that AB is perpendicular to CD. Okay, Next, let's refer to the graph down below right here, okay? We're going to label the point E, which is a midpoint between C and D. Once we label that, we can clearly see that there's two triangles present from A to B, okay? So we're going to try to prove AE is equal to EB so that we can prove the bisector portion, okay? So in order to do that, we are going to make triangles, okay? Make triangles. In this case, AE plus CE squared, AE squared plus CE squared, right, equals the hypotenuse of 6 squared, okay? And then we have BE squared plus CE squared equals 6 squared, using the Pythagorean theorem. In this case, when CE is shared in between the two, we can say that AE is actually equal to BE, okay? AE is actually equal to BE, okay? Because the hypotenuse are the same, okay? So in conclusion, since AB is perpendicular to CD and AE is equal to BE, then AB is the perpendicular bisector of CD, okay? Please remember to write the conclusion on your papers for the exam. Thank you.